So we're going to be talking about multiplying a negative times a negative. And instead of you memorizing a rule like a negative times a negative is a positive times a negative is a negative, positive times a positive is a positive, I wanted you to actually understand why that was true. So what I decided to do was show you a website that has a lot of really cool examples that help you understand why a negative times a negative is a positive. So it's over here at mathisfun.com. I'm going to put that link up on the website, but just so I can go through it with you, I want you to get a visual and see what we're doing. So when you look through it, right here, it says multiplying, and they have a positive times a positive makes a positive, negative and a negative makes a positive, negative and a positive is a negative, and positive negative is a negative. Well, that's true, but let's see why, okay? So right here, they have the two signs. So what they mean by that is when we have right here, the like signs, as in positive and a positive, or negative and a negative. Those are both like signs, right? When you have a positive and a positive, they equal a positive. When you have a negative and a negative, they equal a positive. When you have the unlike signs, like right here, you see that a positive and negative is a negative, okay? Here's their examples. So they said negative 2 times positive 5. So those are unlike signs because we have a negative and a positive, just like right here. So a negative and a positive is a negative. Right here we have a negative and a negative, so we have like signs. So when we have like signs, we'd say that negative 4 times negative 3 is positive 12. But let's do a little further than that and actually understand why. So look, like this example right here, it says common sense explanation. So you have this, and you say, if I say eat, I'm encouraging you to eat. That's a positive, okay? But if I say do not eat, I am saying the opposite. The opposite of a number is a negative, right? Now if I say do not eat, I am saying I don't want you to starve, so I am saying eat. And you can think about that in real life too. You know, you've always heard double negatives. Whenever you hear a double negative, you know, they cancel each other out, right? Same exact idea with math. We have that double negative thing going on. They cancel each other out. We've got a positive again. Direction. This one can be a little confusing, but try to follow along. So they talk about a baby and it's making its first steps. And he moves 2 steps at a time and does this 3 times. So if he starts here at 0, moves 2 steps, moves 2 more steps, and then 2 more, that's like 2 times 3 for a total of 6 steps. Now can step backwards, but still facing the same direction. See, right here, forward, and right here is forward. Now they're going to step backwards 2 steps, and he's going to do it 3 times. So he moves 2 steps, then moves another 2 steps, and moves another 2 steps. He moves 3 times at that 2 steps backwards for a total of 6 steps backwards. Now you can say that he's facing backwards, and he's going to move 3 times at the 2 steps again. So you move 2 steps, 2 steps, and 2 steps 3 times. Now here's where it becomes tricky. You can say that still facing that backwards direction, he's going to walk backwards, but he's going to do it those 3 times. So you can see right here, move 2, and move 2. Like I said, this example might be a little confusing for those of you that are visual. Try standing up and actually trying it. Like get up and do that. Do what this baby just did. Here you go. I like this one, the money example. I always try to think of things in terms of money or temperature. And in this case, money is perfect. So you can say that if you owe 3 people $5 each, you owe a total of $15, or you have negative $15, right? They then say, we like you so much, we forgive the debt. You have just had 3 subtractions of negative 5. So it's like you have added 15, meaning, look right here, 3 subtractions of negative 5. That's what multiplication is. It's repeated addition, or in this case, subtraction. So negative 3, taking it away 3 times, and you're taking away $5 3 times for a total of positive $15. Here you go with the tank. There's a tank that holds 30,000 liters, and 1,000 liters are taken out every single day. What was the amount of water in the tank 3 days ago? We know that the amount of water in the tank changes by 1,000 every day. Sorry, that's a negative 1,000, of course, right? Because it's going down because we're taking it away, so that's a negative. We need to subtract that 3 times. So to go back 3 days, so we would say back 3 days, subtracting 3 days, at subtracting 1,000. So if we were subtracting 1,000 every day we move forward, if we move back, it's like adding 1,000. And if we move back 3 days, it's like adding 1,000, adding 1,000, adding 1,000, which is 3,000. It's the same thing as saying -3 times -1,000 will give us positive 3,000. Make sense? There's a few more examples when they show the multiplication table right here. And you can see the visual of how when you multiply and then when you have the zeros and then when you have the negatives. And this is really cool because it's like a grid. So I think this website has a lot of really good help for you that it's worth looking at again. And I think that will help you understand why a negative times a negative is a positive. Okay, so let's do a little bit of practice to make sure that we understand it. All right. We said that a negative times a negative is a positive, right? So if I said -3 times -3, I know that negative times a negative is a positive, so my answer is going to be a positive, what? Awesome, 9, good job. Okay, that's pretty simple, right? So what if I said 4 times -3? Okay. Now I have a positive times a negative, and I have positive times a negative. Remember, this is like that whole different or unlike terms. They have different signs, okay? So positive 4 and -3, that is negative, whatever 4 times 3 is, in this case is 12. So we should have -12 as our answer, right? Okay, good. But now we need to work on a concept which is difficult for many people, and that's when we deal with those exponents. So we know that if I said 2 cubed, which is to the 3rd power, we know that's like 2 times 2 times 2. 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. Okay, no problem. But what happens if I said negative? Like if I put -2 cubed. Now here's the trick. This is where people like to get messed up. This says, let me put it to you this way actually. If I said the number -2, you would all tell me that says -2 right there. But what if I said 0 minus 2? That's what that says also, right? 0 minus 2. Now if I take away that 0 again, and now I just have -2 right here, okay? If I have just -2 right there, that's like saying the opposite of whatever 2 is. Now, remember when we learned about exponents, we talked about there was a base and an exponent, right? The base held it up. And I said that if anything was not in parentheses, it was not helping up. Remember I said the arms, if your arms are out here, they're helping, that person's helping to hold up the exponent, right? So like in this case, if I said 2 to the 3rd power, and then I said, let's say I said 2 times 2 to the 3rd power. This 2 is the only thing holding up that exponent, right? This 2 right here, it's not a part of it. Now, if that 2 reached out its arms and they put that parentheses around it and it looks something like this, it would say 2 times 2 to the 3rd power. Now we know that that is all the part of the base, right? This 2 and this 2 are both part of the base. That gets me back to here with this -2 to the 3rd power. So I'm going to show you over here what that means. 2 to the 3rd power up here you said was 2 times 2 times 2. Over here, this does not say -2 times -2 times -2. Doesn't say that because that -2 is not in parentheses. That negative sign is not part of that 2. What that means right there is do whatever 2 to the 3rd is and then make it the opposite. I'll show you in a little cleaner version. So I'll come here and make a cleaner page. So if I were to say -2 cubed, that means negative, and then you do 2 times 2 times 2. 2 times 2 times 2 is what again? I think it's 8. Yeah, let's go with 8. Okay, 8. Now put a negative sign in front of it. Okay? So this says -2 to the 3rd power. So we put negative or the opposite of whatever 2 to the 3rd is. So the 2 to the 3rd is 8, and the opposite of that is -8. Let me show you over here what this means. If this was written like that, it means -2 times negative 2 times negative 2. Okay. Negative times a negative is a positive. A positive now times a negative would be a negative. So let's do this. Negative 2 times negative 2 is positive 4, right? Now multiply 4 by negative 2. 4 times negative 2 is negative 8. Now you're going to look at me and say, well, negative 8 here and negative 8 here, that's the same answer, right? Well, what about if I did the exponent to a different number, maybe say an even number? I'll show you what I mean now. So look here, if I said negative 2, let's say this time to the 4th power. Okay, it's even. All right. This would be like saying negative 2 times negative 2, times negative 2 times negative 2. Okay. Negative 2 times negative 2 is positive 4. Times, over here, this negative 2, bring that one down. 4 times negative 2 is negative 8. Now we say times this negative 2. Negative 8 times negative 2. Now we have a negative times a negative. And what do we say a negative times a negative is? Positive. So negative 8 times negative 2 is positive 16. But if I wrote it like this, negative 2 to the 4th, remember like my last example, just 2 is this base. That's like saying 0 minus 2 to the 4th. Well, let's do 2 to the 4th. 2 times 2 times 2 times 2. Easy enough. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Oops, that's a 6. 16. Now, this says 0 minus that. So 0 minus that. Well, if I said 0 minus 16, what's 0 minus 16? It's negative 16. Negative 16 here is my answer. Negative 16 and positive 16 are different numbers. So right here we have negative 2 as the base, and over here it's just 2 as the base. Now I know that's a little tricky, and that's why we're going to practice a little bit more with that.